In this video, I'm going to introduce two very special right triangles. The 45-45-90 triangle, sometimes called an isosceles right triangle, and the 30-60-90 triangles. These two triangles can be extremely powerful for us in trigonometry. I've mentioned before that, especially in trig, I like to know a few huge topics really well, and then we can apply them to a lot of different situations. This is another one of those topics, like SOHCAHTOA, that we can apply to many problems in the future. All right, so let's start with the 45-45-90 triangle. Now I have a right triangle here with two angles, other than the 90 being 45. Now, this is called an isosceles right triangle because these two sides are going to be the same because they're across angles that have the same measure. So those two sides are the same, and we don't know what they are, so we're going to call them x. The hypotenuse of a 45-45-90 triangle is always the side times the square root of 2. And we need to remember this relationship. We need to know this diagram here for sure. Now, I can give you an easy proof to come up with that hypotenuse just using Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. So our leg x squared plus our other leg x squared is going to be equal to our hypotenuse squared. Combining like terms, we get 2x squared equals our hypotenuse squared. And then we'll take the square root. So we get our hypotenuse h, but over here on the right, because the operation between the 2 and the x squared is multiplication, we can do the square root of 2 separate from the square root of x squared. So this becomes x times the square root of 2. So again, we really want to remember this relationship that the two sides are x, the hypotenuse is the square root of 2 times whatever the side is. Then we have our 30-60-90 triangle. So right angle, 30 degrees for one angle, 60 degrees for the other. The shortest side of this triangle is always across from the 30-degree angle. And we're always going to label that side x. The hypotenuse is twice the short side. And that's how I think of it, and that's how I'm going to say it a ton of times throughout trig, that this is the short side of our 30-60-90 triangle, and the hypotenuse is 2 times the short side. And then it's not easy to go from the hypotenuse to the long side, so I always, come back to the short side, and then our long side is the square root of 3 times the short side. Again, we need to know this relationship. This is going to give us so much information and allow us to do so many problems in the future. So let's put it to some work. This would be something I would definitely, put on a note card if you're a note card person, each one of these. So we want to find the missing links of this triangle. I got a right angle and a 45. That forces this angle to be 45 as well. So here we have our isosceles right triangle. Since our angle measures match, our legs have to match as well. So this one's 5. And then to go from the short side to the hypotenuse in a 45-45-90 triangle, you simply multiply the leg by the square root of 2. We're getting y to be equal to 5 times the square root of 2. Our next example is a 30, 60, 90 triangle. They didn't label this one down here, but we know that's going to have to be 30. Remember that our short side is across from the 30-degree angle, and then our long side is across from the 60. And it's always easiest to get the short side first if it's not given, because the relationship from the short side to the hypotenuse and the long side are easier than trying to go from the hypotenuse to the long side or the long side to the hypotenuse. Now this one, maybe you need to check your diagram again. It's a little bit harder to remember. But the short side is half the hypotenuse. And maybe you even want to write something like that out in words. So you could also think of it as the hypotenuse being 2 times the short side. And then our long side is the square root of 3 times the short side. Alright, so I'm given the hypotenuse. I'm going to find the short side. The short side is always half of the hypotenuse. So this is going to be 6. And then to go from the short side to the long side, I'm going to multiply the short side by the square root of 3. The way that I help myself remember these, which one's the square root of 2 and which one's the square root of 3, I remember that the square root of 2 goes with the one that has 2 sides and 2 angles that are the same. And then the square root of 3, I don't know, it just jumps out at me because it's like 30 and 60 are like really easy multiples of 3. So it jumps out at me that the 3 goes with all these multiples of 3. Again, super powerful triangles. You want to know these diagrams or put it in words. I always like stuff in words over just formulas, but we're going to use this a lot in the future.